So our first problem on inverse of a matrix is if A, B, C, D are four invertible matrices. Invertible matrix simply means non-singular matrix. Determinant of all these four matrices is non-zero. So if A, B, C, D are four invertible matrices such that the product of these four matrices is identity matrix, then question is we have to find B inverse. Now see, three types of questions are generally asked on this concept. Suppose if this relation is given A, B, C, D, this equals to identity matrix, and here if I ask you what is the inverse of matrix A, so you can see that one matrix is A, another matrix is B, C, D, and the product of these two matrices is identity matrix. So I can say that the second matrix is inverse of first matrix. So this means inverse of matrix A, this will be simply B, C, D. So here you don't have to do any calculation, you can directly say that A inverse is BCD. The second type of problem that is asked is find inverse of matrix D. So now you can see that one matrix is ABC, another matrix is D, and the product of these two matrices ABC into D, this is identity matrix. So this means D inverse, this will be ABC. So if these type of problems are asked, either A inverse, then you can directly write BCD. If the question is find D inverse, then you can directly write ABC. Now here the question is we have to find the inverse of this matrix B. See, in case of matrix, you cannot change the order. We know that matrix multiplication is not commutative, so you cannot write AB equals to BA. So here if I have to find inverse of matrix B, then in that case your first aim will be you have to separate this B. So see how I am going to separate this matrix B. The relation that I have is A, B, C, D, this equals to identity matrix. So since we have to separate this B, so I am going to multiply both sides by A inverse, and this will be pre-multiplication. So first I am going to multiply this side by A inverse, and on right hand side also first we have to multiply this by A inverse. So this is the relation that you have now. Multiply both sides by A inverse. Now A into A inverse, this will be identity matrix, so you will get B, C, D, this equals to A inverse into identity, so this will be simply A inverse. Now we are going to multiply both sides by D inverse, and this will be post multiplication. See, in case of matrices, if you have this relation A equals to C, then you can write AB equals to CB, but you cannot write AB equals to BC. This will be incorrect because on left hand side you are doing post multiplication, and on right hand side you are doing pre multiplication. So either you can do post multiplication on both sides or pre multiplication on both sides. So here I have multiplied both sides by D inverse, and this is post multiplication. Now D into D inverse, this will be identity matrix, so I will get B into C, and this will be A inverse D inverse. Now again, since we have to separate B, we are going to multiply by C inverse on both sides, and again this is post multiplication. Now B into C into C inverse, this will be identity matrix, so you have B equals to A inverse D inverse C inverse. Now the question was, so this relation we have obtained. Now the question was we had to find the inverse of this matrix B. So this means inverse of this matrix B, this will be A inverse D inverse C inverse, inverse of this matrix. Now we know that in case of matrix multiplication we have to use the reversal law for inverse. So now we have to write in reverse order. C inverse inverse, this will become C inverse inverse, then D inverse inverse of this matrix, then A inverse inverse. Now if you take inverse of a matrix twice, then you will get the same matrix. So this means inverse of matrix B, this will become C, then inverse of D twice, so you will get D, then A. So this is inverse of matrix B. So in any type of these problem, your first aim will be you have to separate that particular matrix, and then you have to take inverse on both sides. So this was very basic problem. Now the next question is, this question is based on the concept that we have just learned now. This question was asked in GATE 2016. So the problem is if M to the power 4, M is any matrix, so M to the power 4 is an identity matrix, and it is given that neither M nor M square nor M cube is identity matrix. Then the question is for any natural number K, we have to find M inverse. So see, it is given that M to the power 4 is identity matrix. So I can write this relation as M into M cube, this will be identity matrix. Now see the second we have two matrices, one is M, other is M cube, and the product of these two matrices is identity matrix. So this means the second matrix M cube is nothing but the inverse of first matrix. So this is the equation that you have. Inverse of this matrix M, this will be simply M cube. Now all the options are in the form of M to the power 4k plus 1, 4k plus 2 and so on. So now we have to see which option is correct. So if I place k equals to 0 here, okay, then you can see that you will get M to the power 3 here, right? I mean the inverse of this matrix is M inverse is M cube. Now if M inverse is M cube and M to the power 4 is identity, so this means M to the power 7, this will be M to the power 4 into M cube. M to the power 4 is identity matrix, so this will be identity into M cube, which is matrix M cube. Similarly, M to the power 11, this you can also write as M to the power 7 into M to the power 4. M to the power 7 we have already seen, it is M cube. M to the power 4 is identity, so this will be M cube. So if M inverse is M cube and all these values are same, M to the power 7 is also M cube, M to the power 11 is also M cube. So inverse of this matrix will be M cube, which is M to the power 7, which is M to the power 11. So all these matrices are inverse of matrix M. So you can generalize this result and you can write that M inverse, this will be nothing but, you can see that this is 4 into 0 plus 3, this is 4 into 1 plus 7, 4 into 1 plus 3, here you have 4 into 2 plus 3. So all these values you can write as 4 to the 4k plus M. And for different value of k, you will get all these numbers. If you place k equals to 0, you will get M cube. If you place k equals to 1, you will get M to the power 7 and so on. So this will be the general formula for inverse of the matrix. M inverse is M to the power 4k plus 3. So the correct answer is option C. Now these two were very good questions. After this, we are going to see some other problems based on inverse and adjoint of a matrix. So these are the next two problems on inverse and adjoint of matrix. This question is, a matrix A is given and 10 times matrix B is given, and it is given that B is inverse of A, then we have to find the value of alpha. Now see, there are a number of ways to solve these type of problem. One basic approach will be find the inverse of matrix A and then compare these two matrices. It is given that B is inverse of A, so simply by comparison you can find the value of alpha. Another method is that if B is inverse of A, so this means A into B, this will be identity matrix. So form an appropriate equation, product of these two matrices A and B, this will be identity. So from here calculate the value of alpha. So let me show you how to do this. See, if 10B is this matrix, this means B will be nothing but 1/10 of this matrix, right? So you have one matrix A, another matrix B, and the product of these two matrices is identity matrix. So I can write this relation as, first our matrix A, this will be 1 minus 1, 1, 2, 1 minus 3, 1, 1, 1. So this is our matrix A, and matrix B is 1 by 10, this multiplied by 4, 2, 2, minus 5, 0, alpha, 1 minus 2, 3. So you have one matrix A, another matrix B, and the product of these two matrices is identity matrix 1, 0, 0, 0, 1, 0, then 0, 0, 1. So the product of these two matrices A and B, this will be identity matrix. Now we have to find only that element which will give us an equation in alpha. So maybe we can find the element in first row and third column. So if I multiply the first row and the third column, then I should get 0, right? This multiplication of first row and third column, this will give you that particular element which is in row 1 and column 3. So now if I multiply these numbers, I will get 1 into 2 plus minus 1 into alpha plus 1 into 3, and you can see that element in first row, third column is 0. So this is the equation that you have in alpha. Now you can easily solve this equation. So 1 plus 2, 3, 2 into 1, 2 plus 3, 5. So from here you can see that the value of alpha that you will get is 5. So in this way you can easily solve. You don't have to calculate the inverse of this matrix A. Simply write A into B, this equals to identity matrix, and then equate that particular element which will give you an equation in alpha. For example, you can also do second row, third column. second row third column, this should give you the element in second row third column, which is 0. So from here you will get one linear equation in alpha, and by solving that particular equation you can find the value of alpha. So this was very simple question. Now the next one is, this is based on the properties of adjoint and inverse that we have seen. If A is any square matrix of order n such that determinant of adjoint of A is determinant of A to the power 9. Now the question is, we have to find the value of n. So we have seen that adjoint of A, this was nothing but determinant of A to the power n minus 2 into matrix A. This was our formula. Now here the equation that you have is, from this relation you can write determinant of, and in place of adjoint of A, you can write determinant of A to the power n minus 2 into A. So I will get determinant of A to the power n minus 2 into matrix A, and this is nothing but determinant of A to the power 9. Now see, you have this matrix A and a number determinant of A to the power n minus 2. So if I want to take this number outside, then I have to take nth power of this number outside. We have discussed this property several times. Determinant of k into A, this will be k to the power n into determinant of A. So here if I want to take this number outside the sign of determinant, I have to take nth power of this number outside, and this multiplied by determinant of A, this will be determinant of A to the power 9. So now you can see that this will be determinant of A to the power n minus 2 raised to the power n. So this will be n into n minus 2 into determinant of A. This will be determinant of A to the power 9. Here I have used the property of indices A to the power m to the power n. This is A to the power m into n. So similarly we had n minus 2 raised to the power n. So n into n minus 2. Now we can write this as, since the base is same, we can add the exponent. So this will be n into n minus 2 plus 1. This equals to determinant of A to the power 9. Now we can equate the exponent. So from here the equation that you will get is n into n minus 2 plus 1. This equals to 9, which means n square minus 2n plus 1 minus 9. So this will be minus 8 equals to 0, which implies n minus 4, n plus 2, this equals to 0, which will give you n equals to minus 2 and plus 4. Now obviously the order of a matrix cannot be negative. So this minus 2 is not acceptable, and therefore the correct answer is 4. So this was very simple question. Once you know the properties of adjoint and inverse, you can easily solve these type of problems. So the correct answer for this question is 4. Okay, so now we are going to see these two problems on probability density function. So the first question was asked in engineering services in 2017. The question is, a random variable x has the probability density function fx equals to k into 1 by 1 plus x square. X is from minus infinity to plus infinity. The question is, we have to find the value of k. Now we have learned that if here fx is given, fx is k by 1 plus x square, and the range of x is from minus infinity to plus infinity. Now we have learned that if fx is probability density function, then in that case integration minus infinity to infinity fx dx is 1. This was our third property. If fx is probability density function, then fx is always positive. Second, probability that x is from a to b is given by integral from a to b fx dx. And this was the third point, that integration from minus infinity to plus infinity fx dx, this is always 1. So I can write this as integration minus infinity to infinity k by 1 plus x square dx. This will be 1. I can take k outside, tan inverse x, and the limit from minus infinity to plus infinity, this will be 1. So this implies k into, now if I place the upper limit, I will get tan inverse infinity, which is pi by 2, minus, if you place the lower limit, then you will get tan inverse minus infinity, which is minus pi by 2. So this value will be 1. So this means k into pi by 2 minus minus plus, so this will become pi is 1, and finally you will get k equals to 1 by pi. So the correct answer for this question is option B. The value of k will be 1 by pi. So these are very simple problem. Once you know the properties of probability density function or the definition of probability density function, then you can easily solve these type of problems. The second question is, this one is also a similar problem. This was asked in 2016 in computer science. The question is, the probability density function on interval a to 1 is given by 1 by x square, and outside this interval the value of function is 0. So this means our fx is, this is the definition of fx. Fx is 1 by x square when x is from a to 1. On the interval a to 1, fx is 1 by x square. So this is the value of fx when x is from a to 1 and is 0 otherwise. So outside this interval the value of fx is 0. Now the question is, we have to find the value of this unknown a. So again, since fx is probability density function, integral from minus infinity to infinity fx dx, this value will be 1. So I can write this as integral from minus infinity to a fx dx plus integral from a to 1 fx dx plus integral from 1 to infinity fx dx. This will be 1. I am breaking this integral into 3 parts: minus infinity to a to 1, 1 to infinity. Now before a, the value of fx is 0. Okay, fx is non-zero only when x is from a to 1. So before a, value of fx is 0, so this term will become 0. After 1, again the value of fx is 0, so this term will become 0. So basically we have this relation, integral from a to 1 fx dx, this value is 1. Now when x is from a to 1, the value of fx is 1 by x square. So I can write that integration a to 1 fx is 1 by x square dx, this will be 1. Now we have to solve this relation to find the value of a. So integration of 1 by x, this will be minus 1 by x, and the limit is from a to 1. Now in order to avoid calculation mistake, whenever you have this minus sign, then convert this minus to plus and change the limit of integration. So I will get the integration from 1 to a. Now this value is 1, and from here we have to find the value of a. So you can see that this will give us 1 by a minus 1 is 1. This means 1 by a is 2, which means a is 1 by 2, which is 0.5. So therefore the correct answer for this question is a equals to 0.5. So these two were very simple problem. Once you know this relation, that integration minus infinity to infinity fx dx is 1, if fx is probability density function, then you can easily solve these type of problems. Our next concept is mean variance and standard deviation. So first we'll see how to calculate these quantities for discrete random variable, and then we'll see the same thing for continuous random variable. So in case of discrete random variable, the first step to calculate mean variance and standard deviation will be, first you have to draw probability distribution table. So this will be the first step. We have seen how to draw probability distribution table. We have to create this table which will have 2 rows. On first row we have to write the different value of x, and in second row we have to write the corresponding probability. So suppose the values of x are x1 with probability p1, x2 with probability p2, x3 with probability p3, and so on, and the last value of x is xn and the corresponding probability is pn. So first step, you have to make this table, and now we are going to see how to calculate these quantities: mean, variance and standard deviation. So the first one is mean. Now this mean is also called expectation or expected value. So mean or expectation is same thing, and this is represented by either you can write x bar or you can write this as expectation of x. So ex. So the formula for this will be expectation of x will be simply p1 x1. You have to multiply the value of random variable x which is x1 with the corresponding probability p1 plus p2 x2 plus p3 x3 and so on up to pn xn. So this will be the formula to calculate mean or expectation or expected value. So expectation of x, this you can also write in the form of summation pi xi. So this will be the expected value or average value or mean of this random variable x. Now second thing is variance. So second we have to calculate this variance. Now the variance is represented by sigma square, and the formula to calculate variance will be, this will be simply summation pi xi minus x bar square. Summation pi xi minus x bar. X bar is the mean, so you have to subtract mean from each of the elements, and then pi xi minus x bar square, this will give you the variance of the random variable x. So for example, if you want to write this in expanded form, so this will be p1 x1 minus x bar square plus p2 x2 minus x bar square, and so on up to pn xn minus x bar square. So this will be the formula to calculate variance. So this x bar, which is mean, is constant, that you have to take from here. This value is nothing but x bar or mean. So if you want to calculate variance, then you have to multiply p1 with x1 minus mean squared plus p2 x2 minus mean square, and so on. So this is one formula to find variance. Another formula for variance is, another formula which is more popular is that if I have to calculate variance, then this will be summation pi, and you can write this as xi square minus 2xi into x bar plus x bar square. We are using the formula of a minus b square, so this will become, now if I separate this, then I will get summation pi xi square minus x bar is constant, so I can take this outside, 2 times summation pi xi plus again x bar square is constant, summation pi. So this will be the value of variance sigma square. Now we know that sum of all the probabilities, summation pi, is nothing but 1. We have seen this in our earlier discussion, that if I add all the probability p1 plus p2 plus p3 up to pn, then I will get 1, and summation pi xi is nothing but the mean. So you will get summation pi xi square minus 2x bar, and this is also x bar mean, so x bar square plus this x bar square. So finally you will get summation pi xi square minus x bar square. So this is another formula to calculate mean. Mean sigma square is pi xi square minus this mean square. Now sometimes this is also written as this variance sigma square. See, summation pi xi is expectation of x. Summation pi xi, this is expectation of x. So here we have summation pi xi square. So this you can write as expectation of x square minus this x bar, which is mean, is nothing but expectation of x. So I can write this as expectation of x squared. So this is again a very important formula in for calculating variance of any random variable. The sigma square is expectation of x square minus expectation of x squared. So this was all about mean and variance, and the last topic that and the last formula that we have to learn is a standard deviation. So we can discuss the formula for a standard deviation here. The third important point is a standard deviation. A standard deviation. So this standard deviation is represented by sigma, and this is nothing but a square root of variance. So once you have calculated variance, the standard deviation will be simply a square root of variance. So these are the 3 formulas that you have to remember. The first one was expectation of x or x bar, and this was summation pi xi. So this was the first formula. Then second formula is for variance of x. So this is the definition of variance, but generally we will be using the second formula to calculate variance. And you can write the same formula in a slightly different manner as expectation of x square minus expectation of x square. And finally the standard deviation is nothing but positive square root of variance. So these are the 3 formula. Now we'll take one example and we'll see how to calculate mean, variance and standard deviation. So our first question is, find mean, variance and standard deviation of number of head. Find mean, variance and standard deviation of number of heads in tossing 2 coins. So if we toss 2 coins simultaneously, and x is the random variable which is representing number of heads, so the question is we have to find the mean, variance and standard deviation of number of heads. So the first step will be we have to draw the probability distribution table. Now for that, first we need to find the sample space, and we have to see what are the different value of x and their corresponding probability. X is representing number of head. So if we are tossing two coins, so we know that in that case the sample space will be head head, head tail, tail head, and tail tail. So this will be the sample space. These are the four possibilities. We are tossing two coins. Now x is representing number of head. X is number of heads. So the probability distribution table will be, there are three possible value of x. X is either 0 or 1 or 2. So first I am going to write x, and then I will write the corresponding probability. So the value of x will be either 0 if we are getting two tails. For these two outcomes, the value of x will be 1, and if we are getting two head, then it means the value of x will be 2. So the possible value of x is either 0 or 1 or 2, and their corresponding probability will be, x is 0 with probability 1 by 4, x is 1 with probability 2 by 4, and x is 2 with probability 1 by 4. So this will be the probability distribution table for number of head in tossing two coins. Now our job is, we have to find mean, variance, and standard deviation of this x, which is representing number of head. So first one, we are going to find the mean. The formula for mean was, this expectation of x is summation pi xi. So this will mean p1 x1 plus p2 x2 plus p3 x3. So p1 is 1 by 4, x1 is 0, so this will be 1 by 4 into 0, plus p2 is 2 by 4, x2 is 1, so this will be 2 by 4 into 1, plus 1 by 4 into 2. So finally you will get 0 plus 2 by 4 plus 2 by 4, this will be 4 by 4, which is 1. So this means you are tossing two coins, then the average value or expected value of number of head, this will be 1. This simply means if you repeat the same experiment number of times, then the average value of number of head that you are getting, that will be 1. So this was the first result. The second one is, we have to find the variance of number of heads. So the formula for variance was, this was summation pi xi square minus this mean square, which is x bar. So first thing, this will be nothing, this variance sigma square, this will be p1 x1 square plus p2 x2 square plus p3 x3 square minus this mean squared. So now these are your p1, p2, p3, x1, x2, x3. So we have to substitute those values there. So I will get 1 by 4 into 0 square plus p2 is 2 by 4 into 1 square plus p3 is 1 by 4, this multiplied by 2 square, minus mean is 1, so 1 squared. So this will be 0, 2 by 4, you will get 2 by 4 from here, 4 by 4, this will be 1, minus 1, these two will cancel. So finally your variance sigma square is 1 by 2. So mean is 1, variance is 1 by 2. Now we have to calculate the standard deviation also. So standard deviation sigma, this will be a square root of variance. Variance is 1 by 2, so this means standard deviation sigma, this will be simply 1 by root 2. So if we are tossing two coins, then in that case, and if x is representing number of head, then mean of x is 1, variance is 1 by 2, and standard deviation is 1 by root 2. So after this, we'll see how to calculate mean, variance, and standard deviation for any continuous random variable. Okay, so now we are going to see mean, variance, and standard deviation for continuous random variable. So suppose if fx is probability density function, then in that case we have seen these three results. The first one was fx is always positive. If fx is probability density function, then fx is positive for all x. Then second one was probability that x is from a to b. This was given by the formula integration a to b fx dx. And finally, the value of integral from minus infinity to infinity fx dx, this is 1. These things we already know, but these are very important results, so I am writing those things again here. Now, if fx is probability density function and we have to calculate the mean, so the formula to calculate mean here will be mean or expectation. This we will write as ex or x bar, and this will mean the mean or the expected value. So here the formula to calculate mean will be, this will be simply integration minus infinity to infinity x fx dx. Using this formula you can find mean of any continuous random variable with a given probability density function. So see, this one is similar to this third result. Here your left hand side is integration minus infinity to infinity plus infinity fx dx. Now we are simply multiplying here by x. So this will give you the mean or the expected value. Now one more important thing, if you have to calculate expectation of x, then you have x here. So if I have to calculate say expectation of x square, so now this will be integration minus infinity to infinity, and you have to replace x by x square. So you will get x square fx dx. For x you have x here, so for x square you will have x square here. So this is the formula to calculate mean. Now the other two formula that we have to know is for variance and standard deviation. So variance, so the formula for variance, this was represented by sigma square, and this we have seen earlier, this was expectation of x square minus expectation of x squared. This was the formula to calculate variance. Now we can easily, once we know this formula, we can easily find the variance using this concept. Expectation of x square, this will be integration minus infinity to infinity. Expectation of x is x fx dx. So expectation of x square, this will be x square fx dx. So this will be the first term minus the mean square. Mean you have already calculated using the first formula. So we have to substitute that expectation or mean here. So this will be the formula to find variance. And finally we have to see what should be the formula to calculate standard deviation. So standard deviation we already know, standard deviation sigma is nothing but a square root of variance. Standard deviation, this was represented by sigma, and this is positive square root of variance. So first you have to, even if the problem is you have to find variance, first you have to calculate the mean, because in the formula of variance you have the mean here. So first you have to calculate mean, then you can find variance, and finally your standard deviation will be a square root of variance. So these are three very important formula that you have to know. After this we'll take some problems and we'll see how to apply these formula.